Number 25, we are going to graph the equation y is equal to 3 to the x minus 1. And we are going to make a table. We are going to have 5 points, then do the graph. Let's see. Our table will have 3 columns. The first column will be for the x value. I just put on x. And the second column will be for the y value, which we know y, which is the equation, is equal to 3 to the x minus 1. And the third column will be points. And as we said, we will have 1, 2, 3, 4, 5. 5 points. Okay, we will do it with 5 points. Notice that the x is in the exponent. In our situation, this is what we call the exponential equation. If the x is in the exponent, this means we are not going to have any worry about if there's any bad x numbers to use. All the x value will work. Let's begin by putting 0 in the middle. Let me choose when x is equal to 0. And 0 is like the nice numbers, right? And it's like in the middle. Let me put 0 in the middle of my table as well. So if x is 0, y will be 3 to the 0 minus 1. 3 to the x is now equal to 0 minus 1, like that. And we are going to do this by the order of operation. In our situation, we will have to do 0 minus 1 first, which is negative 1. So we get 3 to the negative 1. 3 to the negative 1 is the same as 1/3. Negative exponent turns out to be a fraction 1 over 3 to the first. Okay? So our first point is x equal to 0 and y is 1/3. Okay? And also notice that if x is equal to 0, this point that we get is exactly the y-intercept. Okay, this is also the y-intercept. So 0 is very easy to use, and then it also tells us the y-intercept as well. Once we use x is equal to 0, let's just pick its neighbor numbers. So the next number that we can use, let's pick x is equal to 1. If x is equal to 1, our y value will be 3 to the first minus 1, like that. And once again, following the order of operation, I will have to use the y in red minus the y in black, which is 0. I have to get 3 to the 0, which that will reduce to 1. That becomes 1. So the second point that we get is this 1 in red for x, and this 1 in black for y. 1, 1, like that. Okay? We use 0, we use 1. Why not use 2 for the next one? If x is equal to 2, then y will be 3 to the second power minus 1. Both of these are in the exponent. Let's do that first. 2 minus 1 is just 1, so this becomes 3 to the first. 3 to the first is just a 3, a normal number 3. So this point that we get is x is equal to 2, y is equal to 3. Okay? So far we have 3 points, and perhaps I will just make a graph right here as well. Here is my x-axis, and here's my y-axis. So let's see, I have 1, 2, 3, 1, 2, 3, like that. And then I will also get 1, 2, 3, 4, 5, and maybe a 1, 2, 3. Let's plug in this point, 0, 1/3. So x is equal to 0, which is right here, and y is equal to 1/3. So from here to here is 1. Okay? From here to here is 1. 1/3 is just, you have to cut this into like 3 pieces. So let me just say 1/3 is right there. Next point, 1, 1. When x is equal to 1, y is also equal to 1, which I will just put it right here. We will also have 2, 3. When x is 2, 1, 2. We have to go up 3 times. 1, 2, 3. So it's about right there. So far this is what we have. And as you can see, we only have like the right-hand side of the graph. So we should also go to the negative part of this graph. That means we are going to choose negative numbers for x. Let's use -1 for x. If x is equal to -1, we get y equals to this -1 in red. Well, let me write down 3 first. 3 to the -1 in red, -1 in black, like that. And we are going to do -1 minus 1, which is -2. We will get 3 to the -2. And 3 to the -2 means we will have 1 over 3 squared. Okay? Once again, negative exponents becomes a fraction. In this case, we will just turn this into a fraction, becomes 1 over 3 to the second power. And then 3 to the second power in the denominator, which is the same as 1 over 9. Let me just write this as 1 over 9 right here. Okay? So the point that we get is x is equal to -1, y is 1 over 9. Just like that. Let's also make x is equal to -2. If x is equal to -2, we get y is equal to 3 to the -2 minus 1. And we do -2 minus 1 first, which is -3. 3 to the -3. This, once again, turns into a fraction, which will be 1 over 3 to the positive third power. And this will be 1 over 27. Okay? So another point that we will get is -2, comma 1 over 27, just like that. So let's see how can we graph -1, comma 1 over 9. So it's just that we have to label our picture, just kind of make some reasonable amount of estimation. I know -1 for x is right here, but if y is equal to 1 over 9, it's going to be, you see this right here is 1/3 already. Okay, this right here is 1/3. We just have to go 1/3 of 1/3. So 1 over 9, I will just say it's right about here, I will say. Okay? Right about here. And then if x is -2, the y value is 1 over 27, which becomes very difficult to graph in our situation. But I know x is -2, which is right here. 1 over 27, it's just something that's really close to the x-axis, but technically it's not on the x-axis because that's not 0, okay? So it's kind of like very close to the x-axis, just like that. If you connect all the points that we have with a curve, the equation is going to look like, and let me just do it from left to right. The graph is going to look like, the graph of the equation is going to look like something like this. And let me just go up like that. Okay. And notice that the left-hand side right here, this will never go across the x-axis. It's always going to be like flat. Okay? As we can see that this graph touches the y-axis right here, this point. So this is the y-intercept. Let me just label it on the graph. The y-intercept, which we already know, that's 0, 1/3. 0, 1/3 for the y-intercept. And because this graph never crossed the x-axis, there's no x-intercept. I'll just write this down. There is no x-intercept in this graph. So this is the graph that you need to present. That's it.